Yes, good morning, everyone, and good afternoon to those of you that are sitting in the APAC region. It's fantastic to actually see so many attendees to our very first webinar here at Turbulent Flux. We will go straight into the topic. We have 30 minutes allocated for this webinar, and it will be around the production optimization and how flow simulations enable real-time monitoring and operations support. And with that, let me introduce the agenda that really Johan will speak about. We will first do a very short introduction to Turbulent Flux because I'm aware that not every one of you is so very familiar with our company yet. And then we will look into how and where flow simulations sit within the life cycle of an asset, and also where our approach sits within the life cycle of an asset. And there is two key capabilities that we want to highlight today, which is understanding the real-time data access for monitoring your wells and pipelines, and the self-adjusting capability that we worked on our technology approach to assure best performance. And ultimately, it is all about tackling together with you your operational challenges and making it possible to go from a reactive to a proactive approach when it comes to optimizing your production. So a couple of words about us here. We are a flow simulation software company, a quite new one, based out of Oslo, Norway. And of course, there is a key value here that I want to highlight that it comes with no question, and that is we want to deliver as accurate and quality output as possible within our flow simulations. But secondly, it is important to highlight that we are equally so focusing on the accessibility of such complex technology, and that we need to tackle because we understand it is a complex and difficult task. And our ambition truly is that any operator in this world should be able to consider flow simulation technology for their producing asset. And with that, we are looking so much into automating very complex work processes and workflows. We are looking into integrating tools efficiently in your control room. We are looking into making deployment easy for you. And we are trying to really challenge the norm here in making solutions like ours maintenance-free or as close to maintenance-free and cost efficient as possible. So this is where we come in, the quality and accuracy and the take on accessibility in the market. And we can back this up with approximately 200 years of accumulated domain experience. We are only 4 years old, but many of us have many years in flow simulation consulting, technology, and business goals. And we have our founding team here coming previously from the SPT group, which was then acquired by Schlumberger. One person I want to highlight is our Chief Technology Officer, Lars Wollebeck, who was the previous lead architect of the renowned Olga software. So with the expertise in mind, we have also taken a very good step into commercializing our approach. And we are, in fact, after such a short time, market proven. We have clients all over the world. And we are working with both offshore operators, but also within the US unconventional market. And the reason why we are so quickly proven is that we have developed our technology through R&D projects with key operators in the market. And I can mention two of those, one being Petronas, who has been working with us on our virtual flow meter, and one being Aker BP, who has worked with us on our stability advisor. So with that approach, we've been able to not only create these capabilities that we understand you as an operator require, but also commercialize this technology accordingly. So this webinar is about exactly that, making you understand how we work with real-time monitoring of the flow in wells and pipelines and how this can facilitate production optimization. In fact, along any optimization KPIs asset-wide within your operations. And I introduce Johan to you. Johan Henriksen is our product portfolio manager. He has been with us for 2 years, but has 10 years on his back with Schlumberger previously. And Johan is the interlink between technology and commercials. So he is assuring that the requirements and the challenges that you as an operator face are taken into account when we are speaking about advancing our technology further. So without further notice, I leave the stage to Johan. I see he has made himself presenter. And Johan, the stage is yours.
Yes, thank you very much for that introduction, Julia. And yet again, thanks to all of you for taking time out of your busy schedules and spending this 30 minutes with us at our first ever webinar from Turbulent Flux. I wish you very welcome to this webinar here. And as Julia has already said, the topic here is production optimization in oil and gas, or how flow simulations enable real-time monitoring and operation support. So in terms of that title, there are 3 key portions of that one that I would like to emphasize that are really close to heart for us at Turbulent Flux. The first part of it is the production stage. The production stage of the life cycle of an asset is really where we are focusing our efforts. That's where we see our position in this. Then we see, and we are really focusing on production optimization, so the optimization aspect of this. And the way we do that is through flow simulation. So those are the 3 key portions in this. And of course, even though we are focusing on production, optimization and flow simulations as such are very versatile tools. So in terms of that, I will introduce this in the setting of those components. So if we start out in that, looking at optimization as such, it's a very versatile tool that you can use. You can use it to achieve any goals that you set for yourselves. It's about the objectives you define, and as you will realize, it will offer you different ways to actually achieve that. So if we look at an example here, we can see that optimization as such offers truly many ways to roam. An example here, just to introduce it, it's imagine yourself in Italy on vacations, wanting to travel or drive from Venice to Rome. You put the destination into your favorite route planning app and you realize you get different options. You can go by the fastest route, having more time in Rome to see the sights. Or you can say, I'll spend a few days in Rome anyway. So let's avoid the toll roads, save some cost on the drive, and instead spend that on entrance fees, nice Italian cuisine, and a better hotel. Or you can take the point that highways are dull and boring. I want to see the countryside, visit a vineyard or 2, and make the most out of this drive. It's all about your objectives and what you wish to achieve. And the same holds true in any type of application of optimization. And if we look at the oil and gas industry, we can look at this slide here, courtesy Rystad Energy, and it shows us the shift in focus within the industry over the past 15 years. 15 years ago, oil prices were booming, there was an upcycle, and it was all about materiality. It was about the volumes, it was about production growth and reserve replacement. But then came the down cycle, oil prices plummeted, and while you were still obligated to deliver the volumes you had in your contracts, you now had to take cost into account. You needed to investigate lower break-evens, more cost-effective ways of producing. So cost comes in, perhaps not as an objective, but even more so as a constraint. And if you then look at the past few years, sustainability has become a focus area, and both in terms of financial sustainability, you need to have your assets sustainable and give you the payback, but also in terms of environmental sustainability. A high focus on reducing CO2 emissions, reducing the CO2 footprint, but then being carbon effective in the production, because whether people like it or not, oil and gas will be part of the energy mixture. So optimization here is also key. So you see here a broad range that comes in. And if we look at the timeline here, 15 years, we realize that many of the assets in operations today were then designed and developed with a different focus. And that is important because if we realize it, once you put the steel in the ground, it's very expensive to make changes. So you need then to find ways to adapt to ever-changing requirements using the hardware that is already in place. And this is where flow simulations enter. This one here shows the life cycle of an asset starting from the exploration phase, and not much room there for flow simulations. It's about the seismic, it's about geology, geophysics, and about finding the hydrocarbons and the reservoirs. But once you have located it and you start to look at developing an asset, flow simulations enter. It enters in the design phase, it remains throughout the production phase, and it's also utilized when you move toward end of life and into abandonment. So if we look at this, we can see where flow simulations, or rather transient multi-phase flow simulations that is close to heart for us, comes from. And where it started was really in engineering design. Transient multi-phase flow simulations entered the stage in the late 1980s, early 1990s, and has ever since been a commodity. And it has been claimed to be the technology that really facilitated long distance transport of multi-phase flow. Before that, you were producing more locally, you were separating your phases. Long distance transport was predominantly through single phase pipelines. But with this, you could then go longer, further, deeper, and it has been then a driving force toward, for example, subsea developments. So you have found your hydrocarbons, you want to develop it, you look at some different concepts for this. For an offshore asset like the one exemplified here, it may be investing in a new FPSO, or it may be considering tying it back to an existing asset. So to understand how to best do this, what you do is you call up your experts. You bring in your brains, you give them the frames within they are to work, where the hydrocarbon sits and where you want to transport them. They then bring out their simulation tools and they look at different realizations. They look at how to do this throughout the life of the asset, from first gas or first oil through peak production and then into abandonment, and seeing which design would be the one that best suits this asset throughout. So they then come up with a suggested design or a couple of designs, and it's handed off then to a committee making the final investment decision. So this is where it comes from. But once you put the steel in the ground, you start operating, you start asking yourself the question, am I truly operating in an optimal fashion? And this is where you then yet again turn to the same experts, turn to the same software tools out there, and you ask yourself, am I operating in an optimal fashion? And this is the stage where you know what your asset looks like. You know how you should model it to represent reality. But you also, in addition to what you had in the design phase, you have information about the production. So you can now provide them with information about the production. And why is that important? Well, it is important because you really need to calibrate these models to truly represent what is going on in reality. There are many good options out there, and simulators are out there that are performing well. But if you look at that, they are performing well across the range of assets. They are performing well on average. And the one thing we know is that nothing is ever truly average. So if you want them as performant as possible, you need to calibrate. So you provide your experts with the latest production reports, they create the models, they calibrate their models, and then they look at different scenarios, different operations, and then they can suggest an optimal operating procedure that can then be handed off to operations. Okay, you're happy with that. You know that you are now operating in an optimal fashion, but then you realize I wasn't operating optimally last week, and in a few weeks' time, I'm unlikely to operate optimally again. So how can I achieve continuous optimal operations? The challenge here is that experts are not a scalable resource. You can't put one expert to sit on one asset 24/7, making sure that it produces optimally. So what is there for, I would say, a few assets globally, and that is a very small portion of the total number of wells and pipelines, you have real-time monitoring. What you do here is that you bring in a vendor or a service company to calibrate the simulation tools that you have used in the previous stages here, and then they connect them to the data. This means they can then provide you with a virtual window into your production. But the challenge still remains, the same challenge as you had before. You need to know that you're operating in an optimal fashion, or sorry, I should say you're simulating reality in an as accurate fashion as possible, and you need to calibrate. And this is then typically done by maintenance agreements, having the vendor coming in every 6 months or so, recalibrating the model. So
Johan, could I interrupt your thought here, since you are on the calibration aspect, and there was a question by one of our attendees on it. How does the calibration aspect work, and how is it typically done?
yes, so very good question. And what you typically have is, you know what is being produced, you know how it is flowing, you know how your asset is behaving. So you can then take that behavior into consideration, and you can then calibrate your simulation models so that they mimic that in an as good fashion as possible. So that means if you look at the latest production profiles, for example, you can then see how to calibrate it and to capture it. The challenge with this, as we see it here in Turbulent Flux, is that that is a manual workflow. You're not truly relying on the data, and I will come back to this a few slides from now, where we should say that you're not just connected to the data, consuming the data, but you should have models that are actually driven by the data and self-adjusting. So that's really where we see a step change requirement in how you manage and handle real-time monitoring or real-time aspects of flow simulations.
Yeah, thank you, Johan, and also to the rest of the audience. Feel free to bring up any questions, of course, now during the course of the webinar, or after the webinar as well. So thank you for taking this question, Johan.
Yes, thank you, Julia. So, okay, real-time monitoring, as we said, it gives you then a snapshot of what is going on right now in your asset. If you're lucky, you have then also configured alarms that will tell you if some challenges lie ahead. You can also calibrate or configure, I should say, advisors that can then tell you how to operate in a best fashion. For example, if you've been operating below turndown rates, you're ramping it up, you can have advisors that will tell you what surges to expect. The challenge here is that you can't foresee every eventuality, so predefined advisors are not always feasible to use. And you may then be able to have full scenario mode doing that, but you're then looking at one simulation at a time, and that makes it challenging to do true production optimization. So if we look at the current status, it is very often that you can split this into two, and you can look at the different aspects of online versus offline. The online systems, as we said, connected to data, providing you insights continuously. But then for most assets, you're relying on offline workflows for your production optimization, for your operations support. And the connection between the two domains is, I shouldn't say that it doesn't exist, but it is limited. You may be able to extract a simulation model from a real-time system to use it offline, but that means that you need to carry out manual labor when you do it. And if you want to redo the same thing a few months down the line, you need to redo the same workflow because you then download a new model. You are not operating on the model itself. So that is where we at Turbulent Flux see it, that there is a paradigm shift required, and you shouldn't see a split between online and offline. If there should ever be a split, it should be between the design phase, the pre-production, and the production phase. Pre-production, the steel is not in the ground. You can look at very many different scenarios and realizations, but once you move into production, you know that there is one single model that would represent the as constructed asset. And to us, that should be a living asset model. It should be up to date, reflecting what is actually there. If you swap a choke or a pump, you should update the model, and you should make sure that that revision is the one that represents reality right now. And that model should then be consumed in real time for production operations and for production optimization. So if we look at that, and if we look at how we want to achieve this and how we mean that this should be done, is that you should not only have a living asset model, you should have a self-adjusting living asset model. A model that not only represents the asset as it is today, but it represents it in an up-to-date fashion, providing up-to-date insights. Furthermore, we believe in an open technology access. These online systems should not be closed and managed by a vendor or a service company. It can be configured by a service company, it can be configured by any third party or by yourselves, and the access to that model should be there. The model should then be in the same fashion connected to sensor data, but it should then be driven by the sensor data. The data is there, the data connectivity is there, the data has, through the digitalization over the past decades, become available. There's no need that you should bring in a man to do the job, a person to do the manual labor to do the recalibration or the self-adjustment. You should be able to set that up as automated calibration workflows, ensuring that this is always up to date. This means that you can then provide the real-time insights, but you can then also access the same model with your own personalized workflows, working with it. Instead of downloading it, working offline, you create workflows on top of it that are then reusable. And then you can make this available to anyone, anywhere. Also, as it says here, it offers insights into past, present, and future operations. It means that you can go back and look at events in the past. You can look at how you operated something in the past and see if there's potential for improvement. And then you can take those learnings with you into the future and allowing you to operate in a more proactive way. So just to round up then, the data is there. Data platforms are becoming commonplace, but the data is not fully utilized. The way you should do that is by having self-adjusted living asset models that are staying up to date all the time. And then on top of them, you provide different consumption modes. Real-time modes, if you have wells, you can then implement, for example, virtual flow meters like our Flux VFM. For common challenges that you want to monitor continuously, you can then pre-configure advisors like Flux Stability Advisor, the one Julia mentioned, developed together with Aker BP, where we then look at flow instabilities and how to best operate an asset to avoid instabilities that cause upsets. But then open technology access, and that is key. No system can ever be complete, so it's important that you or a third party that you provide access can go in, do the work, and then build on top of the core technologies that we are offering. And by that, you can achieve best informed decisions always. And by that, I conclude and hand it back to you, Julia.
Thank you so much, Johan. A fantastic insight here. We got actually a lot of questions in, and we are restricted a bit on time, so we will take a couple of. But what I want to highlight is, of course, all these questions will be answered. If not specifically now, then we will get back to you on them. There was quite a few questions here. One more time on this reactive. From reactive to proactive production optimization, ultimately what you concluded on here. If you can give some more remarks as to how we want to achieve that from a technology perspective and accessibility.
Yes, so from reactive to proactive, I mean, when you work in a disconnected fashion, you work with limited resources as the experts would be, you're often then, as you say, reactive. You're not continuously making sure that you are operating in an optimal fashion. So you're often chasing yourself, trying to make sure that you're operating in an optimal fashion. For us to be proactive, it means that you can have access to the model and you can then act on it and look at it and say, I'm going to make an operation, I'm going to make some changes tomorrow. You have the model there, you can work with it, rather than calling up on the experts, having to recalibrate the model, which is time consuming, and then you may not do it because you're constrained on time. So that's really where we say this is proactive, and that is by having a self-adjusting living asset model and access to actually use it for any purpose that you want.
Thank you, Johan. And I think we can take one more question here. There is a question in the audience about which multiphase flow simulator, transient multiphase flow simulator is used behind this concept. And maybe you can tell us a little bit more about the Flux simulator that we have developed.
Yeah, okay. So yes, good question. And in this webinar here, we were focusing on the broader picture. We didn't go into our core technologies, but as Julia said, we have our own in-house developed flow simulator, transient multiphase flow simulator called Flux Simulator. As such, it is our technology throughout. It's not relying on any flow correlations or other components from other vendors. So it's been developed by us, been developed on the existing literature, and of course conservation of mass, momentum, and energy. The focus though we have taken when we've developed this is that we have said production is our key focus, and by that real time is also our focus. So in developing it, we have done it with real-time simulations in mind. So it needs to be fast. You need to be able to not only capture real-time, but to do advisors, scenarios on top of that. It needs to run multiple times real-time, and it needs to be robust. So that is truly then the core of our simulation capabilities. We could go into further details on how we then achieve these self-adjustments, so on and so forth, but I would say that please reach out to us after this webinar if you want to know more. And if there's a big interest in those things, we may come back to it in a later webinar as well.
Exactly, Johan. That's a very good point. So all your questions here will be answered, and in fact we are looking then into also making these or putting these types of discussions into future webinars. Maybe a very last question about the software, and if it does simulate in the cloud or if it's installed in the user's own system.
So being this, as we said, as Julia said in the introduction, being a 4.5-year-old company, our focus here was to then have a cloud native technology stack through and through. It's been developed for cloud and to benefit from the benefits you have through a cloud environment. As such, it's been containerized. It is possible to move the technology across cloud platforms and potentially also on-prem if there is a need. But that one then restricts a bit on what can be done, and to fully utilize the power of these tools, I would say that they greatly benefit from a cloud environment, but no doors are closed there.
Excellent. So there is many more questions, and as I said, we will get back to you. I just put my camera back on. So we are running out of time, but thank you so much for your interest. We will attend to the questions. We are excited to run many more of these webinars around our technology approach and solutions. And be aware that we have recorded this session, so you will, in a day's time, also receive access to the recording, which you can then use to reconsume or, of course, share with peers that you think should see this webinar as well. So thank you so very much, Johan. Thank you so very much for attending. I wish you all a very good remaining day and evening, and hope to see you soon again. Bye.
Thank you.